All right, good morning, folks. Zach Hubeck with Wave and ISP Supplies. Guys, we're so excited to bring you this webinar today. I have Craig Muller on the line with us from Tarana and Dennis Tapati from Tarana. Craig is one of their well-versed and very experienced SEs. Dennis Tapati has been in sales leadership and sales for many years. A couple of great friends on the line. And then I also have a buddy in Jonathan Nicholson on my team who is going to be helping us out with Q&A today. So again, my name is Zach Hubeck. I do marketing for Wave and ISP Supplies here in the States. And this webinar, ladies and gentlemen, is all about video surveillance over Tarana solutions. We know the G1 solution. They've just announced a G2 solution. And when you think about traditional point to multi-point solutions in rural America, you think about far distances, you think about people that are in residential areas far away from each other, not a huge bit of density, but now we want to bring an additional angle to you guys with the Tarana G1 and G2 solution in point to multi-point surveillance scenarios. So Tarana has proven they can handle a lot of density, and we thought no better than video surveillance to handle a high density situation where we have many clients being those surveillance cameras. And Craig is going to walk us through the portfolio, the philosophy, and the strategy around why you should be taking a serious nod at video surveillance solutions over Tarana multi-point. So Craig, I'm not going to steal any more of your thunder there, my man. Folks, if you have any questions, please do type those into the chat and the Q&A. Jonathan's going to be monitoring that throughout the presentation. We may interject and say, hey, Craig, we got a great question here and lob it over. But sit back, folks, and enjoy this presentation. I think we'll need about 45 minutes here. And Craig, the floor is all yours, my man. Thanks for doing this.
Thank you. Thank you, Zach. Jonathan, thank you. Hi, everybody. Craig Muller with Tarana Wireless. Really happy to be here today. You know, we've really concentrated on the WISP market for the last 4 years. And you know, over the last year, we've really seen some great developments in the vertical spaces, especially video surveillance. Those of us that have been around a long time have seen a lot of platforms move into that space. Speaking of being around for a while, Tarana has been around for 15 and a half, almost 16 years now, headquartered and founded in Milpitas, California. You know, as a WISP provider, where we really cut our teeth, you know, we're passing a lot of locations. There's a lot of operators that have adopted our technology very successfully. You know, seeing is believing is something we talked about and still talk about, because some of the things that we are able to do in the field are pretty fantastic. And until you see them with your own eyes, you don't believe them. But we've had a lot of adoption over the last 4 years. We are in a very good financial position, very solid financial company. Really did well indeed. We just saw today there was a lot of movement from the NTIA finalizing some awards. If you look through the awards, those that say fixed wireless access or licensed fixed wireless access, they're probably talking about Tarana, and with good reason. Lots of really smart folks here at Tarana, a whole cast of PhDs, a whole bunch of patents revolving around this technology. I like to tell everybody we are an R&D company at our heart. These great leaps in technology that have been put forth over the last few years, you know, don't come out of the ether. It's hard work by, you know, a whole load of people behind the scenes. This is a proprietary technology, and you know, 4 years ago, people would whisper that. Don't say that out loud; you might scare people. But really, it's this proprietary nature of this technology that allows us to continue to expand the horizons of the silicone that we develop. We make nothing but base nodes and remote nodes. That's what we call them: base stations, subscriber units, whatever you want to call them. We're talking about multi-point only. We don't do point-to-point radios today. It's strictly multi-point. And then everything is wrapped around a cloud solution. So this is 100% cloud-based, called the Tarana Cloud Suite, multi-homed into AWS. And of course, everybody's going to ask in their head, well, they just had an outage. We did not. Multi-homed is for a reason, right? If you have one geographic challenge, you're not taken down like you were if you were just in the Northeast data center. And that's a very well thought out topology, and it's really rung true for the last 4 years from a reliability standpoint, and really put that to rest. This is a fantastic page here. There's a lot of information we're going to go over here. If you have any questions, certainly don't hesitate. We're an integrated solution only. We don't have any parabolics. We don't have any 6-foot cellular arrays we're going to need to put up. What you see there on the left is your typical base node. That's the G2, just a little bit larger than the G1. And our remote node sitting there on the right-hand side. That one's actually straight above my head right now at my parents' house in Arizona. And I'm very happy to have it. Being, in the ultra rural, that's a big deal. But this is a product that does everything everywhere. I know that sounds, like a little bit of a chest bump, and it is because this radio walks the walk and talks the talk. Massive MIMO antenna array under the hood of the base node, multiple teraflops of computational power. This is a very powerful chipset that we're bringing to bear here. And because of this proprietary chipset and the powerful nature of it, we've unleashed these holy grail items, the things that are going to make your head turn when you see it in action. Digital beamforming on both sides. Why is that a big deal? 25 years ago, as an operator in Phoenix, I would bounce off of buildings, off of glass, and then the sun would come up. That reflection point would change. My reflection point would change, and then I'd be missing my mark. I might catch some of that RF and provide, a bit of that capacity that I was giving before the sun came up. But at the end of the day, I couldn't make that change dynamically. Because of the beamforming nature on both sides, we're honing in on that reflection point. We're able to change our waveform up to 5,000 times a second to make sure that we're triangulating precisely. That allows us to use reflections very, very well. We like multipath reflections because in those reflections, there's data for us to harness. Our radios are dual carrier at the heart of them. In the G1, 2 carriers up to 40 megahertz each in CBRS. Again, we're beholden to what the SAS will provide to us, right? It could be as low as 210 megahertz channels. We're twice the spectral efficiency of our competition in CBRS. So at the end of the day, even when we bring our second 40 megahertz carrier, we're quadrupling what the capacity of our nearest competitor is. And that's a big deal. And we're able to go into the foliage much deeper than any of our competition when it comes to CBRS. We don't transmit at any higher rate. That would be a violation of the FCC rules. We just hear so much better than everybody else with our phased array. The data that everybody's been hiding in their horns and their parabolic, they've been hiding from it because it's going to be detrimental to their wanted signal. We're going to capture those, out of phase and latent packets and process them in real time and aggregate them to the Ethernet port. We want to see that RF. In 5 gigahertz and 6 gigahertz, and I really don't talk too much about 5 gigahertz anymore because 6 gigahertz is really taken over, especially in the major cities, because the spectrum is so available and so clean, and you're working in typically a SUP of 5 gigahertz, which is why you're looking for options, right? It's one of the major challenges in the video surveillance world using wireless today is how much interference is happening in 5 gigahertz from other operators, from yourself, from Wi-Fi. All of that noise out there really makes it a challenge. 6 gigahertz has been a real lift to the industry. In 5 and 6 gigahertz, we only do 40 megahertz carriers. A few years ago, that would have scared me too. But what we're doing at Tarana, and I'll explain that in a second, overcomes these challenges, both mentally and technically. Again, 2 carriers of 40 megahertz each. In The G2 platform, I could do 4 carriers of 40 megahertz. And I'll talk about G2 a little bit more here in a minute. The big value of this radio when I first came over after doing this for 20 plus years, half of it is as an operator. And one of the main reasons I got out of the industry was because of the interference. It's something called frequency reuse of one. On the best day, all the other manufacturers out there can do frequency reuse of two, which means I'll use one channel of 40 megahertz here, and I can use the same one 180 degrees opposed. But I couldn't use them east and west. I'd have to go grab another carrier, non-overlapping from the north and south, and run them east and west. And that was pretty cool 5 years ago. But the ability to run the same 2 carriers or 4 carriers going north, east, south, and west without meaningful self interference. I want to point that out. There is some degradation that's caused by doing that with our 490-degree sectors, but our capacities are amazing. 2.4 gig, 3.2 gig, 6.4 gig of aggregate capacity, depending on how your radio is configured. So a little bit of degradation, 10, 15%, you don't even know you've lost it. Anybody else that tries to do that, including the big boy LTE folks, they're going to lose about 40% of their overall capacity out the gate, which is why they highly recommend that you don't do frequency reuse of one. To me, that is really the first leg in our interference mitigation stool. The second one is we're able to change our waveform to intercept inbound interferers. 12 to 15 of those. We can, dampen them, keeping them away from our radio head, where we're going to see that sort of interference. Nobody else can do that with one. And we're able to keep that RF away from us to operate in a much more cohesive manner, unencumbered by massive interference, the things that make you want to change. The third leg of that still is something called ABIC, is frame level identification and correction of interference, cancellation of interference in real time. So when we get that to the remote side, whether it's the base or the remote unit, we're not asking what does this say? Can you send it again? We say, oh yeah, we know what that is, and we correct it even more and aggregate it to the Ethernet port. Retransmissions are the hallmark of a poorly designed network, and almost every wireless network out there suffered because over time they get degraded, because they get overloaded, they get interfered with, the foliage grows up. This is a product that's going to overcome those in real time. So reuse of one is a massive benefit. And, like everything else, everybody was a little skeptical of that. We're running it in very dense metro NFL cities today. Thousands of remotes, hundreds of base nodes out there, and by and large running the same frequencies over and over because we don't self-interfere with ourselves. That's a huge advantage. We're a 10 gig SFP plus interface from our radio head down to the switch down at the cell site, or on your building, wherever your transmission location is. So we're running both our data and our management potentially over that optical. We also have an out-of-band management Ethernet port, so we can completely separate those. And that's what's happening in our larger cities today, separating data and management, for security requirements. Our scheduler really is pretty special. We call it 4-dimensional space-time frequency MIMO ranking. All of this is happening in real time, deciding who's going to be on the beamform as it's created. Our ranges are, these are TDD timing ranges. So we have different network profiles, which are our transmission ratios. We don't quite go symmetrical, but we offer so much more bandwidth, even in the asymmetrical operations that we do offer, is head and shoulders above, what anybody else can provide. We do have the ability to even go out to 30 kilometers. It's probably not applicable for video surveillance, but our wireless ISP partners, are reaching out that far, especially with line of sight in those western states where they don't have as much foliage as the East Coast. Our CBRS radios can be very compatible with the timing of LTE frame type 2 subtype 7. So if you were interested in using CBRS, and we have clients that are doing that today, to backhaul camera feeds, especially those that are, you know, much deeper in the foliage than the unlicensed 5 and 6 gigahertz are going to take you. CBRS is definitely an option. Especially in areas where you might have other LTE out there. The G1 radio rates out at 275 watts, a neg 48 volt power. The G2 is 425 watts. Uh, Seems like a lot until you start adding up everything that you're getting, right? Um, We'll talk about that a little bit. Our GPS receivers built into our radio. All of our base nodes have a GPS receiver. Our 6 gigahertz remote nodes, as well as the new RNM multiband radio, has one. The 5 and CBRS remote nodes do not. The remote nodes, to me, again, are really what make these things go, right? There's been beamforming, in the world for many, many years, not to this level, but on the base node only, on the base station side, on the tower side only. And that's still left you wanting because, you're out there with a 1 foot flat panel that's 10 degrees or a little 5 or 4 degree parabolic out there pointing, trying to get your best measurement and hoping that when the wind blows that your link didn't go down. More than likely your link goes down. With our radio, it's a little bit different because it's just like the Big Brother base node, just in a smaller format. It's still doing beamforming. It's still doing the nulling of interference. It's still doing the ABIC. Okay, it's the same chipset in our base nodes that are in our remote nodes. So we don't go down market. And find some off-the-shelf Wi-Fi chipset. We're putting our power pack right into our remote nodes because there's a lot of value there because of the things that it can do. Because there's problems on both sides, right? Of the equation. There's interference on the base node side. There's potentially interference on the remote node side, and they could be different interferences. So if these are thinking independently and dealing with them independently, that's great, and that's what we're doing today. These remote nodes can be 800 meg to 1.6 gig aggregate, depending on we're running 2 carriers or 4 carriers, and depending on the remote node. And I'll walk us through the remote node portfolio here shortly. Again, beamforming on the remote side, so it's seeking out reflection points as well. PoE powered anywhere from 32 to 50 watts on our PoEs. Again, they're doing the ABIC. Super, super easy to install. When we first started doing this 4 years ago, we were a little bit different, a little bit different terminology, a little bit different thinking. But when that clicks, everybody's like, oh my gosh, it's the easiest radio in the industry to install. And they're right. Because it does all of the thinking or a lot of the hard thinking for you, right? It's making decisions, that we no longer have to do, or, in a lot of cases, the least motivated, least trained, least paid individual is out there hanging that remote node, making critical decisions for your company multiple times a day. This radio helps deal with that. We've got a great handheld app to help you align and commission these radios, and makes it very, very simple. And I really appreciate the thought process that we're gone into it. In September, we released the G2 base node. This is the second generation antenna technology, same chipset that's inside powering the G1 and G2. It's just new antenna technology, and it's off the charts. This is a 4 carrier piece of hardware. We've basically taken the G1 CBRS radio, the 3 gigahertz radio, and the G1 5/6 gigahertz unlicensed radios, and pushed them together. So we're getting the CBRS 150 megahertz, we're getting the 5.8 Uni 3, we're getting the 40 megahertz carrier in Uni 4, and then we're getting the big chunks, the 12, 40 megahertz chunks in Uni 5 and the 8 in Uni 7. So it's about 850 megahertz of spectrum in the unlicensed side, and then you add that to the CBRS. So we're now running four carriers, so four independent sets. And there's a bunch of different options of how you can run these radios, right? So a lot of people are running two CBRS and two 6 gigahertz. That's a great way to do it because people have been deploying CBRS and 6 gigahertz today out in the field. All of those remote nodes that you deployed previously to G1, they could all come back to a single form factor, and you could take those other two radios, the G1 radios, and repurpose them somewhere. You know, it's the G1 radio is not going anywhere. I'd like to be clear about going anywhere anytime soon. I'd like to be clear about that. It's still the second best radio, and in some cases, the best radio in the industry, depending on your deployment scenario. If you're not, you don't need CBRS, maybe you don't need a G2. But the G2 brings, all of the flexibility to the table. I like G2 very much in four carriers of 6 gigahertz. Um, I can run four carriers of 6 gigahertz on my G1 in something called X2 software mode, which takes my all of my antenna elements for offense, right? I was using half of my antenna elements in G1 for defense. That's how I was doing my nulling. I can do all four carriers, and I lose some of my nulling in G1. In G2, all of that comes back. I lost a little gain by doing X2 and G1. All that gain comes back in G2 if I'm running 4 6 gig carriers. So it is a, super long-term solution. The G1 radio and X2 mode is running in major urban cities, NFL cities all over the United States today without any challenges. 5 years from now, 10 years from now, there's going to be more 6 gigahertz in those environments. You're certainly going to see more noise creep over time, and the G2 is going to deal with that, much more readily than the G1 radio. But uh, I have no challenges deploying either of those today in any location. The number of radios that you can connect to these base nodes is just, off the chart. The G1 radio, we spec that out at 209 end users, and that's doing at least 100 meg in the download, right? We're talking about connecting video surveillance clients up, 30, 50 end nodes, multiple devices hanging off of each one of those seems to be, the way that people are going to deploy our radios in these environments. If you're only putting a single camera, potentially more than that. Again, depending on how you're set up. Are you recording locally? Are you streaming constantly? All of those things will come into play at the end of the day, and we'll work through those numbers together. Again, the existing RN portfolio can connect back to the G2 radio. And when we look at what they did from G1 to G2, it's like supercharged it, right? This new antenna technology, really supercharged what we're doing at the end of the day. Went from digital signal processing of 7 teraflops. It's like a billion floating mathematical calculations per second, right over my head. We're doing 7 of those on the G1 base node. The G2 is 20 teraflops. So just ramping everything up to a different level. Again, 4 carriers versus 2 carrier centric G1 to G2. A lot more carrier flexibility, right? Because I'm able to use, all the different spectrums, on the G2 radio. And then the nulling to me, we're talking about, how many of these null points we can create, in my 90-degree sector. 7.2 million nulls per second. Seem like an awful lot to me. We're doing 19.6 million in G2. So just taking all of the things we learned from the field and transferring that into the next generation product is what we've done here. Very exciting stuff. Sprung upon us in that early September week 2 months ago was the R&M. We all knew that there was a multi-band remote node coming out, but as far as we knew, it was early next year. That unit's is shipping today. Exciting stuff about this particular remote node is it can connect to any of our base nodes, regardless, G1, G2, CBRS, 5 gig, 6 gig. It can connect to all of them. Might be only in 2 carriers, but it can connect to all of them. Again, squishing together the CBRS remote node as well as the 5/6 gigahertz remote node to give us a 4 carrier centric remote node. 1.6 gig aggregate capacity on this unit. I can run 4 independent carriers. Again, 2 CBRS, 2 6 gig, 2 CBRS, a 5 and a 6 gig, 4 6 gig. Really it's up to your imagination and your line of sight at the end of the day. CBRS is going to go farther into the foliage. Our 5 and 6 gig radios will have you scratching your head. How are they doing this? Because we'll get so much farther than any of the 5 or 6 gigahertz unlicensed that you've seen in the past. We will get into near line of sight and non line of sight with these products, and you'll go, where's the reflection coming from? It's coming through the foliage. And it's not reflection, it's more collection, right? At that point. But reflections off of off of any metallic glass block surfaces, we're taking these reflections and harvesting them. And you're not seeing any degradation there. We're a company that shows you a path loss number, empirical value. And when you see the wind blow, the other cameras go down because their backhaul is now being blocked by blowing trees, or you get maximum pixelization. Our radios are adapting, right? They're looking at those new gaps that are happening in the trees, and they're receiving data through those gaps, and they're transmitting back through those gaps in real time. And they're constantly evaluating that environment. So from a video surveillance standpoint, one of the great things about this product is it's going to overcome a lot of these reasons why you're using bounce shots. You're using micro pops. You're using point-to-point, less expensive 60 gigahertz radios, to connect a pole that you can see with a pole that you can't see. And at the end of the day, every time you step off that macro, you're probably going down in quality. R&M is a very exciting product. Some folks have talked about making it standard G2 and R&M, and you couldn't go wrong with that. But there's options out there, and I like to say, pick the best remote node, pick the best base node, what works for you. And some of that has to do with financials, and some of that has to do with technology. So looking across the top there, we actually have 5 remote nodes available today in our portfolio. I expect that to grow by several more over the next 12 months through some new innovation. But our CBRS radio, the RN3, it's a 2 carrier up to 240 megahertz carrier platform, and it's going to talk to the G2 radio with appropriately configured CBRS channels, or it's going to talk to the G1 CBRS BN. As we move across the 5 gigahertz, the 6 gigahertz, those are 2 carrier radio on the 5 gigahertz. The RN6 is 2 carrier, or it can be a 4 carrier with the software setting. It's not an upgrade, it's just a software setting. And just tell it, I want you to run 4 carriers. And that can connect to the 6 gig radio as well as the G2 BN multi-carrier radio. And then we have the RNV. The RNV is a 2 carrier, 6 gigahertz antenna technology. It's a little more rectangular, as you can see there, but it is 2 carriers only. Same chipset in that radio, 20-degree beamform instead of a much wider aperture that our normal square remotes have more than 55 degrees main lobe. So much more directive. So if you're shooting through a gap between a couple of trees in the near field, this R&V is probably a great selection because it's got a very narrow aperture. Um, the last one again is the RNM, the 3 gigahertz, 5, 6 gigahertz multiband radio. And again, it can talk to all of our base nodes, which is again very exciting. And that radio will again is shipping today. Why have we been using fixed wireless access? And just to be clear, we call ourselves ngFWA. You'll see that in a slide here, next generation fixed wireless access, because, you know, uh, the next page will kind of explain that. But cost effectiveness, at the end of the day, trenching fiber to hook up cameras and surveillance systems probably isn't going to happen, especially in our major cities. The ability to deploy these things very rapidly, right? You call me up today and say I need a solution tomorrow. That's not out of the realm of possibility, right? It's pretty doable. Having the flexibility, you know, across different terrains, different geographies, right? Wireless can go everywhere, and fiber can go a lot of places. Um, Reliability and speed. You've got a whole bunch of technologies, right, that really came out over the last 10, 15 years. Your 5G, your millimeter wave. Those folks, built, a platform that wasn't really made to do what they're doing, but it does it very well, right? 5G FWA, that has some problems, right? You don't own it; somebody else controls it. At the end of the day, and you're not going to be the favored partner. Their cellular is going to be. Millimeter wave. You're talking about typically point to point or very short point to multi-point, but you can't have anything in between you and it, right? At the end of the day, you must have line of sight, clear line of sight. Anything less, and you're gonna be truck rolling. And the integration with public safety always made this a wireless very attractive. But there's downsides, right? Again, that line of sight, if you don't have it traditionally, a lot of people shoehorned a lot of 5 gigahertz in places that it shouldn't go, and they get marginal results at the end of the day. Uh, Signal interference and fading. Again, it's what got me out of the industry is the interference. All of the different reflections that you used to see that were always very harmful. They worked against you. Weather, right? Depending on what spectrum you're using, and if you're using higher frequencies for point-to-point radios, you're going to get washed out when it rains, right? 5 gigahertz, 6 gigahertz, CBRS, pretty impervious to weather of all sorts. Network congestion, and that's where Tarana is really going to shine on top of everything else. Is the radios that are out there today can't handle the capacities that are being asked to do today. People are getting higher definition cameras. They're adding different applications to, hey, can you put this on that backhaul? And most of the time people said, yeah. And then eventually you break it. And how do you fix it? You put up another radio, add more interference to the equation, more congestion, more latency, until ultimately you're at a point where having a conversation with somebody who runs airport security, and I won't narc them out because half of their surveillance network is down because their wireless network is down. And I'm like, isn't that like some sort of violation? And the reason was they collapsed their network because they put too much on it. And how do they fix that? And if you don't have the expertise, you may be waiting for a while to have somebody, come to your rescue. But Tarana has, and it's really geared towards that last page, fixing the problems that men and women have created in the industry. Number one is, really dealing with the non-line of sight. How do we do that? Again, real smart people developed a really nice system on a chip that really deals with non-line of sight. Again, better listening capabilities at the end of the day, able to take data and be correcting it, in midstream, so that it's not, brand new bucket mess and go, I don't know what that says. Um, being able to deal with interference, right? That is, always been the biggest challenge. That how do I know that I put something up and that a year from now somebody else is going to put something up and interfere with us? Number one, the Tarana system is more than capable of handling itself. If you get too close to it, more likely the other radio platform is going to suffer much greater harm than the Tarana radio, and we're able to deal with that interference. And in a lot of cases, you're not even going to know that that interferer is there, because we're going to mitigate and cancel the interference. And the third one is really about multiplying the capacities. Getting more bandwidth out of the same amount of spectrum, or less spectrum, because we're more spectrally efficient at the end of the day. To add those, extra things, those increasing bandwidth requirements. Cameras aren't getting, slower or requiring less. They're getting better, and they're requiring more. 5 to 10 meg for high def. Up to 25 meg. For ultra high def. I thought some of these, bi-spectrum cameras that are out there looking for thermal imaging, I thought they were much higher capacities, but typically, maybe up to 12 meg required. License plate readers, and this one surprised me because I thought, they would be even less. But depending on where they're located, how many cars they're seeing, how many lanes they're seeing, right? It could be up to 16 meg per camera, and you might have multiple of those. I look at the city of Pittsburgh, which, a bridge and a tunnel, right? Hundreds of them, and they all have surveillance on them. They're all reading license plates. They're all doing thermal imaging and other funky scans, right? And those all take bandwidth. And if you look at their deployment, it's just stacking a licensed radio on top of each other until you harm yourself, and then you hope that you can stop. Shot spotter, minimal bandwidth, but when you're talking about the triangulations of those, that bandwidth calculation can go up a little bit. And then the other one is, the last thought in a lot of places, or sometimes the first thought, is Wi-Fi for first responders, right? In areas of congregation, where your cellular network may not be prioritized for first responders, having a lifeline for them, high capacity Wi-Fi where they can do calling and data, collection. That's a big deal. Very exciting stuff. And we say that, bring that bandwidth to us, and let's lay it on. We've got several. Yes.
Craig, yeah, if I can interject here, if we can go back two slides to the interference mitigation slide that you had there. One of the questions that came in is, how can G1 and G2 coexist on the same tower without interference? If we could expand a little more on this before we move on.
Sure. It's really the same for any of our radios. I have a gentleman that has 6 gigahertz base nodes on one stick, pointing in the same direction, 3 feet vertically apart, all running different frequencies. And that would be the key, right? I can run 360 degrees on the same frequency, but I can't overlap sectors on the same frequencies. So depending on what you're running on G2, let's just say you wanted to run, half CBRS, half 6 gigahertz, not a problem. The G1 radio below or above it probably is not running CBRS, right? Because you've got 150 megahertz of spectrum, and if you're using 80 megahertz of that, that doesn't leave 80 megahertz for a second radio. Maybe you run a smaller amount, but more than likely somebody else is already using spectrum there. So doubling up in CBRS really is not very common. But maybe you double up in 6 gigahertz, and that second 6 gigahertz radio, G1, G2, would be running different frequencies. And you can do that all day long.
Thank you. Appreciate that.
No problem. Good question. So this is I'll call this a pending case study. We have several video surveillance networks that are happening right now in the eastern part of the United States, in NFL cities. Actually, pretty good teams this year. Well, two of the three, and they're yet to be shown the light, right? They're not public yet. We're under NDA. I can't really talk too much about them. But we all know who the legacy fixed wireless manufacturers are in the public safety space. And we all know how much they've innovated in the last few years, right? Camera operators have innovated. You know, the auxiliary system manufacturers have innovated, right? And they demand more. So we already know who's out there, right? And the time is now to go and replace those and move our surveillance into the next level. So these folks had, you know, a very large wireless surveillance network in an NFL city. Interference is the main problem. A lot of it is self-interference at the end of the day. More 5 gigahertz on top of more 5 gigahertz, and then we're going to throw some 60 in there, and you know, it becomes a mess at the end of the day. So our proposal is very simple. Let's get rid of all of those micro pops and go back to the macro with us, because we have the capability to, you know, go in and get those end points that are, you know, in the clutter, that are in the trees, that are around a corner. We're going to use reflections. We're going to use our superior listening capabilities of our phased array to gather that data and provide what this client told me was the best looking video he's seen in 25 years in the industry. I haven't seen it for 25 years, but I'll take his word for it. He sounds very excited. So does the city, because these networks have been out there for a long time as well, and they are maintenance intensive. They're constantly going out there and, you know, having to either replace radios, where mounting hardware has you know, corroded and deteriorated over time, go and replace the mounting hardware. You know, again, you know, started my dad's chainsaw up that's been sitting out there for 20 straight years without being fired up here in Arizona. Try that out east, right? Everything rusts, everything corrodes over time. So there's a big deterioration going out there, and you know, not just the technology, but also the physical hardware, that it's time to go. So you've got a hodgepodge out there, micro pops, you know, little clusters, little one-offs, right? You know, with varying power backup systems. You know, at the end of the day, you're chasing camera outages across, you know, a city of several million people, and that makes you know, no sense. 2 months ago, we started deploying in the first city, and again, we're in 3 of them with them now. They threw up, you know, our standard G1 starter kit, a BN, 5 remote nodes, and called back 2 days later and was like, "You got to be kidding me!" And you know, they just kept coming until they've deployed all 5 of them. The city's thrilled, and we're working on you know, the next deployment here before the end of the year of an additional 200 camera points connecting to 3 additional base nodes. So very exciting. And the best part about this was it was predictable. You know, and we'll do the planning for you. You know, we need the high point sites, right? Whether you're on a tower or a building, we need to know how tall it is, and we need to know the GPS coordinates of where your endpoints are, where your receiver nodes would go, where your cameras are located. And I can run a clutter data plan and tell you what your potential capacities are there in different spectrums, in different configurations, right? I can change my symmetry. You know, if you need 300, 400, 500 meg in the uplink, we can make that happen for you. And it's a very exciting time, you know, at Tarana, because we see you know, a huge opportunity, not just in the United States, but globally, for video surveillance, to kind of get a full refresh. So I'm not sure. Hey, 45 minutes, Zach. You nailed that pretty good. With no practice, I'll take that. Any questions? I know that I had a couple of them. One of them was latency, and latency with our radio 4 years ago, was somewhere in the 20 to 25 millisecond round trip. And I thought, my goodness, going through all of these trees and, bouncing off of these buildings, and I'm seeing that sort of result. That's awesome. And then one of our founders said to me 4 years ago, our scheduler is inefficient and we're fixing it. And I laughed. I routinely see less than 10 milliseconds round trip, even in non-line of sight environments. 15 milliseconds, probably kind of the upper end, on a good link round trip. And that's amazing. We've seen gaming tournaments with some of our bigger clients where they, get in an auditorium and gymnasium and they do online gaming tournaments. And the request from the gamers was, please do it over Tarana and not the fiber because, our reaction times are better. I don't know too much about the gaming world, but that sounds pretty cool to me.
It does. We have another question here, Craig, if we have some time here, regarding G2. If an operator doesn't have a CBRS PAL license, is there a use case to use G2 with GA CBRS and 6 gig?
No. Anytime you use CBRS, you've got to have a relationship with a SaaS provider. With us, it's Federated or Google. You still have to have that because they're going to tell you what frequencies you're going to operate on. You're still going to need a certified professional installer on your team or more than one, to authenticate those installs, regardless of whether they're PAL or GAA. It's not a big deal, by the way. Just had some friends take the test that were, not really of the industry, and they had no problems with it. And it's a really good learning experience about what CBRS is and, how it responds and reacts. And, it's been a good education for me. I didn't do CBRS before I came here, and it is an amazing spectrum. It's even more amazing with the R&D work that the team at Tarana has done to work towards a lossless solution using our 2 carriers. That's another beautiful thing about 4 carriers with us in CBRS and 6 gigahertz. And I intentionally don't say 5 gigahertz because we'll look at it, and if 5 gigahertz is available, it's still a killer workhorse. But in most cases, if you have 6 gigahertz available spectrum, you're going to do the 6 gigahertz. If I'm doing 2 CBRS and 2 6 gigahertz, and I'm along the coastline, right, in 6 gigahertz, in CBRS, the first priority owner is the U.S. Navy and their naval radar. So if you're, along the coast within about 100 miles of the coast, and your radio sensor, there's environmental sensors listening for naval radar and interference for that matter. But naval radar in this case, if they hear it, they're going to tell your radio you have to mute your CBRS channel and go back and ask the SAS for new channels. If I'm running 2 6 gigahertz and I'm connected to that remote with an R&M, for instance, that radio stays up on 6 gigahertz, while we sort out the CBRS reallocation of frequencies, and I seamlessly roll those back in when they're reassigned. So, which is, a nice benefit.
Excellent. Thank you. I have one more for you here. When should I upgrade existing G1 sites versus deploying G2 on new sites?
That is a good question. And, number of end users, right? 209 is the top end for G1. Most people, I'm going to tell them stop at 175. give yourself a little breathing room and a little more scalability, right? At the end of the day. But that might be a good reason to do it. Adding more end users. The current max capacity of the G2 is 256. In a release coming in 2026, it'll be 512 users. So, there's some scalability there. That's probably the best reason is having that number. The other one would be, maybe it's all 6 gigahertz you're looking at. You want to offer higher capacities. X2 can do that, but again, X2 has some gain losses when you go to X2 that come back with G2. So pushing gigabit farther out, pushing higher capacities farther out, into your coverage area. G2 would be, a good candidate for that. Again, with the 4 carriers, I can, push up to, 400, 500 meg in the uplink across one of those. Today, there is some other symmetries that are being worked on in the background, to try to get even more out of that uplink, but that's still a lot of bandwidth today, right? Multiple hundreds of meg in the uplink of clear channel connectivity is a lot of bandwidth. Any other questions? We'd
First shot on my end here.
I was gonna say, feel free to reach out to anybody on the Wave team. Feel free to, and they'll put you in touch with the appropriate regional sales team here in Tarana. Dennis and I are east of the Mississippi typically. We'd love to talk to you some more. This was more of a scratch the surface type of conversation. We'd love to talk even deeper, about what the radios can do. We also have a resources page, and Dennis, if you're out there, if you could maybe throw that up on the chat. This resources page is, chock full of, all of the information about Tarana. Our data sheets, our manuals are there. All of our VLAN functionality documentation is there. A whole bunch of case studies of what people have done, in the past, and we love good case studies, right? Like I said, I'm waiting for, the video surveillance one, probably come trickling out after the first of the year when they get a few more radios, up in the air, make it a little more noteworthy, and we'd love to hear some more opportunities out there and talk about any of them with y'all.
Hey, Craig, looks like we've got a couple more questions that did come in. Dennis, thank you for popping the resources link into the chat. Go ahead and check that out, folks. And then, Jonathan, if you could copy and paste that into our follow-up email to all the attendees, that'd be awesome. We got a couple of anonymous questions here, Craig. So what percent of the max wattage does the BN run at during a typical busy hour for a typical sector loading?
So the G1, I only know the G1 at this point, as far as loading people up, 275 watts is what we say on the highest utilization sectors I've seen out there. May not be the one with the most people on it, right? But utilization somewhere in the 260, 265 range. I've seen that. So, these are real numbers.
Great. Beautiful. Another one, and this is about mounting strategies and RF propagation. Is there any problems with flush mounting a base node on an exterior wall versus freestanding or on a tower?
My only concern would be airflow. There is, in the G1 radio, there's an external fan. On the G2 radio, there is a highly recommended but optional external fan. And if you mounted that against the wall, depending on airflow, and where you're located, right? If you're in, Phoenix, I probably wouldn't recommend it. But if you're in, a cooler climate, you probably get away with it.
All right. Buyer beware of airflow on that back wall. Great points there, Craig. Cool. All right, Jonathan, do you see any other questions? I'm scanning chat. I'm scanning Q&A. Do you see anything else, my friend?
Let's see here. Looks like we did a really good job at answering everything. I don't see any other questions pending there.
All right. I love it. Craig, thank you for wetting our whistle on Tarana and video surveillance environments. I certainly got some good ideas here. Hopefully the balance of the crowd did. Folks, we are recording this. We'll put this on YouTube if you want to listen back on some specific moments that Craig covered. But Craig, Dennis, thank you guys so much for the partnership. Great relationship we have with you guys, and we look forward to some really new, cool innovations and using Tarana in some different environments. This certainly helped the team out here. So thank you so much for that.
Likewise. Thank you, everybody. Have a great
All right,
day and rest
everybody.
of your week.